Hello everybody. Today we will start permutation and combination part 2. Okay. So we covered NPR, NCR and or those concepts and or. So we covered all this in permutation and combination 1. So I expect you guys have seen the previous video and understood these concepts. So let us extend these concepts and build some more layers on it. So let's say you have a four letter word ROSE. Okay. So how many ways can you rearrange these four letter words? So as I already discussed this even in the previous video, let me explain it one more time. So so you have these four letter words and how many ways you can rearrange this among itself. Okay. So how many ways can you rearrange it? Rearrange this four letter word. No repetition allowed. Okay. Okay. There is a reason why I'm discussing this problem. So let's say there are four spots out there. Okay. How many ways can you rearrange this four letter word? So the first spot can be filled up in four ways, right? There are four letter words. First words can be filled in four ways. The second letter can be filled up in second spot can be filled up with three ways. Because one letter it will be consumed by this spot. So we are left with three letters right now. So this spot will be filled up in three ways. So how many ways we can fill this third spot? It is two ways, right? The last spot is one ways. So how many total number ways? Is 4 times 3 times 2 times 1 equals 4 factorial. So how did we solve this problem? We solved this problem by this 4 we got how many ways? Either it can be R or O or S or E. So since there are like there are four ways, so we added it up, right? There are four R's, R or O or S, so there are four ways, so we added it up, and this spot needs to be filled with four ways, and the second spot needs to be filled with three ways. So we did multiply. We put multiply between 4 and 3 and 2, so we put multiply in between, right? So we already discussed all this in detail in the permutation and combination one. So in case you are having some doubt, please see that video before you watch this one. Okay. So the reason, and one more thing we also discussed in previous video. So in this case, ROAC, here order is important, right? Order is important. What we mean by order is important? It means if it is ROSE and ROES, both are we are considering both as different. It's not like there are same four words, four letters are same, so both are same. No, we are considering both as different. So order is important. And what is NPR? Here we are selecting R from N terms. We are selecting R terms where order is important. This is we gave a formula for NPR. We derived that formula in the previous video. And how we derived it? We used and or concept to derive it, right? So basically every problem can be solved by ground principle, like simple and or, but still we also will remember this formalized uh, uh, formula, basically basically this formula NPR, right? So so in this case there are four spots out there, and there are from four spots you have to select four. From four letters you have to select four spots. How many ways can you do when order is important? It should be 4p4. And from NPR formula, which is 4 factorial minus 4 minus 4 factorial. 4 minus 4 is 0 factorial, and but 0 factorial is 1. Okay. Just in case if I have not discussed this in my previous video, I cannot recall if I discussed it. I discussed factorial, that I remember very clearly, but also remember 0 factorial is always equal to 1. Okay. Similarly, 1 factorial is 1, we know, right? 1 times 1 is 1, but 0 factorial is also considered as 1. So NPR is what? N factorial divided by n minus r factorial, right? So in this case, if it is 4p4, from 4 letters we have to select four spots. For r is 4, and order is important. So it's like n factorial 4 factorial divided by 4 minus 4 equals 4 factorial by equals 4 factorial. We got this as answer. Okay. So I guess this is clear for you. Okay. So now let us go a little bit deep into it. Okay. What will happen? What should be similar problem? Let's say we have a problem where the letters are root, where these two letters are same. These two words are same, right? You see, previous problem we had ROAC. All the letters were different. Okay, so let's say now we are discussing about this problem root. Okay, so how many ways can you rearrange this word root? This for there are four letters in this word. We need to rearrange it. How many ways we can do it? And obviously these two O's are same. Okay, so basically let's first consider this O as O1 first O, and the other one as O2, just so that we can distinguish between them, right? So that we can distinguish. So basically when we consider this as O1 and this as O2, so what is the scenario currently? The current scenario is we have now four different letters. Just for our peace of mind, we have considered these two as different, right? But in reality they are not different, they are same. But let's say they are different, and then how many ways can you select? Can you rearrange these four letter words in these four spots? Okay, so the first spot you can select in four ways, right? First spot can be filled up in four ways, from R, O1, O2, or OT. Second spot can be filled up in three ways. Third spot can be filled up in two ways. Fourth spot can be filled up in one ways. Either you can write simple 4 times 3 times 2 times 1, or you can directly also write as is 4p4. Both are the same thing. Okay, but I always prefer this one. The reason is your conceptions becomes more clear, and if it's a difficult problem, then this helps a lot, because sometimes you cannot directly use this 4p4 or 4c4, but if you're confident, then it's fine, you can use it. It's not a big deal. But there are some scenarios in difficult problems when you need to understand what is and what is or. It helps you a lot. Okay, but whatever it is, the answer is same: 4 times 3 times 2 times 1, and this is 4 times 4p4. But this is the case when O1 and O2 are different, right? We already got it for rows. It's a four letter words. It's 4 factorial. We already got it. But in this case, in reality, O1 and O2 are not different. O1 and O2 are same, right? So let's say, so what is happening here? R O1 O2T, they are considering it as one case. Even R O2 O1T, they are considering is as another different case. But in reality, O1 O2 O2 O1 both are same, right? Actually this root and this root is same. Similarly, let's say if it is O1 O2 RT, okay, and it is O2 O1 RT, they are considering these two as different. That's how we are getting this 4 factorial. Okay, this is how we are getting this 4 factorial. So what we are seeing is, so this is like two letters like this. So for every, these two letters can rearrange among themselves in how many ways? If it's four letters, they can rearrange among themselves in 4 factorial ways. So if it is two letters, they could rearrange among themselves as 2 factorial ways, right? For a particular scenario, RO1 O2T, it can be RO2 O1T, right? Similarly, that's how we are getting it as two. You see, two cases. So here we are getting 2 factorial, here we are getting 2 factorial. So basically, for every 2 factorial cases like this, so total number of arrangements we are getting as 4 factorial. Okay, for every 2 factorial arrangements of O1, O2. Total number of arrangements, how much? 4 factorial, right? The total number of arrangements I mean is like for the letter R O O T, O1, O2, T. Okay. So now let's say we don't need 2 factorial such cases. Actually, we need one such case. Even if it is R01, O2 or O2, O1, we don't care, right? We only need one such scenario from this. We need only one case. So for 2 factorial arrangements, total is 4 factorial. So for every one case of O1, O2, total number of arrangement will be 4 factorial divided by 2 factorial, right? Hope you guys have understood this concept. So let's move on, and we will build this concept again. We will discuss another example here. Let's say there is another word, institute. So how many arrangements are there, and it cannot be repeated? How many ways it can, how many rearrangements are possible, and all letters should be used once, just only once. Okay. So you see how many numbers is one, two, three, four, five, six, seven, eight, nine. So we have 9 letters. Okay. And you see here we have like I and I. We have how many eyes? We have two eyes, right? And we have three T's, and the rest are different. Okay. So we have two I's and three T's here. Let's say the first I is, let's say both the I's are different and all the three T's are different. Okay. So I will consider the first I as I1 and the first T as T1, the next I as I2, the next T as T2, third three T as T3. So we have this, let's say we have this word institute. So all everything is different. Let's consider everything as different. So how many possible arrangements are possible when there are 9 letter words? Simple, right? When we have 4 letter words, how many arrangements were possible? 4 factorial. So if we have 9 letter different words, how many arrangements will be possible? 9 factorial, right? We already discussed it quite exhaustively, I guess, right? It's like 9p4, and the first out of 9 spots of first spot can be filled up in 9 ways, like 9 ways, 8 ways, 7 ways, right? So when we multiply it, we get as 9 factorial. Now let's say how many eyes are there? Two eyes are there, right? Although we have distinguished them as different, but in reality they are same, right? So you see in the last example when we have two O's, so there was two factorial cases for this ROOT and RO2O1T. So there were two factorial cases. So similarly, if I1 and I2 are there, so there will be two factorial cases like that, right? Hmm. Like for each arrangement, there will be two factorial arrangements between I1 and I2, like for a same arrangement. Okay. So I1 and I2 will rearrange between them in two factorial ways. Okay. And you see how many T1s are there? One, two, three. So there are three T1s are there. So basically it will be 3 factorial T1 arrangement. Okay. So the overall number is 9 factorial. We have to divide it by 2 factorial and 3 factorial. Okay. I hope you guys understood it, but just want to give one example. Let's say I1 SN T1, I2, T2, U, T3, E. 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say this scenario is there. Okay. Let's say the same is there instead of T1. No, T1 is here. Let's say this is T3, U, T2, U. Okay. The same one here. Let's say we have T2 now. T1, U, T3, E. Okay. Now again here T2, here T3, T1. Now let's say, and rest all are same. Okay. Let's say this is T3 and T1, T2, and let's say this is T3 and T2, T1. Okay, these numbers are all same. So how many ways are there? How many is like one, two, three, four, five, six, six, right? So you see for a same scenario when I1, SN, I2, the U2, E, when all these are at the same spot, so there are six means 3 factorial ways it can be T1, T2, 3, T3 can rearrange among themselves for a when all the rest of the spots are exactly the same. Okay, so that's why. So but we, out of these 6 cases, that is 3 factorial cases, we need only one case, right? We don't need all the 3 factorial cases, because everything is same, right? It doesn't matter if T1 is, this is T1 or this is T2 or this is T3. Until and unless T1, T2 and T3 are in this spot, we are fine with it. So basically for 3 factorial cases, we only need one such case among these 3 factorial cases. We don't need 3 factorial cases. So that is why we are dividing this 9 factorial by 3 factorial. Okay, I hope this is clear now, because I just explained it a bit more, just for some people who might not have understood what I said before. Similarly, for I1 and I2, we have two letters here. So we are dividing two same letters here. We are dividing it by 2 factorial for the same reason. So for 3 factorial cases, we need only one factorial, only one such case. Similarly, for I1 and I2, for 2 factorial scenarios, we only need one such case. So that's why the total number 9 factorial is being divided by 2 factorial times 3 factorial. Okay. I hope this is now much more clear to many of you. So let's say we have another example. Let's say we have this word daughter. Okay. So number of ways the 8-letter word daughter can be arranged so that the vowels are together. How many ways can it be rearranged? Can be arranged. Okay. So how many ways this word daughter can be arranged so that the vowels are together? What are the vowels in this word daughter? A, U, E, right? A, U, E are the vowels in this word. Okay. Now what we will do is, so they are saying the vowels should be always be together. Okay. So let's consider A, U, E as one unit. Okay, let's consider AUE as one unit. So if we are consider AUE as one unit, let's say we have AUE and the rest of the letters D, G, H, T, R. Okay. Now how many ways can we arrange this thing? Considering AUE as one unit, that means it will always be together. It will always be together. AUE will always club together, stick to each other. Okay. So if we consider it as one unit, then how many letters do we have? One, 2, 3, 4, 5, 6. Right? We have six letters then. If we consider AUE as one unit. So how many ways, and all are different, right? Everything is different. So how many ways can we rearrange it? If we have four letters, different letters, how many ways we rearrange it before? 4 factorial. Last time we had 9 letters, how many ways we rearrange it? 9 factorial. This time we have 6 letters, how many ways we can do it? 6 factorial ways, right? I hope you're understanding it, not like if it's 4, it's 4 factorial, because I already said it should be 6p6. You can either do this directly as 6p6, or better yet, better off, if there are six spot 1 2 3 4 5 6, the first spot can be taken by 6 ways, this can be taken by 5 ways, this can be taken by 4 ways, 3 ways, 2 ways, this can be taken by 1 way. So we multiply all of it to get it as 6 factorial, right? Now it's the problem hasn't yet ended. Okay, so see, but in reality, AU is not a same unit, right? It can be, let's say, the same thing. We can also arrange it at AEU, and again the same thing, DH, DGHTR. Okay, so we can rearrange AUE among itself in how many ways? AUE, let's say AU is a single word. How many ways can we rearrange it? All are different, right? So we can rearrange it in 3p3 ways or 3 factorial ways, right? So for each scenario of DGHTER, there are 3 factorial scenarios. AUE can be rearranged within itself for each scenario of DGHTR. So similarly, for another scenario and for another point, another place where AUE is there, we can again rearrange it in 3 factorial ways, right? So basically, then what will be the total arrangements? It will be 6 factorial, and AU can also rearrange between itself, within itself. So we have to do multiply 3 factorial. Okay, I hope this is clear. Now let's say we have another example. We have to select a committee of 3 persons. We need to constitute a committee of 3 persons, needs to be constituted. Let's say we want to form a committee of 3 formed, needs to be formed from what? From 2 men and 3 women. Okay, in how many ways can this be done? Let's say this is the first problem, and how many ways can we s- select a committee of 3%? Needs to be formed, just we need to select a committee of 3 persons from 2 men and 3 women. Any three can be selected. Okay, so how many total persons we have? 2 plus 3, 5. And among these 5 we have to select any 3 persons. Is it a permutation or combination? It doesn't matter if the, let's say these three are the spots and this is person 1, person 2, person 3. If it is person 1, person 2, person 3, or person 1, person 3, person 2, it doesn't matter, right? The order is not important here, right? We have to select only 3 persons. That is important. It's not like a march past. They, where they stand, it is important. If they stand the front line or the middle or the back, it's not like that, right? So it is, the important thing is we need to select 3 persons among 5 people, among which 2 are men and 3 are women. So what we will do, since order is not important, we will do 5c3, right? Or what else we can do? So when order is important, we know it should be 5 ways. The first spot can be filled in 5 ways, second spot can be filled in 4 ways, third spot can be filled in 3 ways. So it should be 5 4 3. And since order is not important, what we do, we divide it by 3 factorial ways. These two are the same things. 5c3 means 5 4 3 divided by 3 factorial. Okay, we just do the, what is the formula for 5c3? 5 factorial divided by 3 factorial times 5 minus 3 factorial. Okay, so basically actually 5 minus 3 factorial is like 2 factorial, and this is 5 factorial. So this will come as this 2 factorial gets cancelled. It will be 5 times 4 times 3 divided by 3 factorial. Okay, now how many of this committee would consist of? There is a next part to it. How many of this committee would consist of one man and two women. Okay, so how many consist of one man and two women? So this, now what we have to do is, you have to select one man from a set of two men that you have, right? And you have to select two women from the set of three women that you had, right? So how many ways can you select one man from a set of two men? It's 2c one ways you can select. And there is an and. So you have to multiply it also, right? And what is the next condition? You have to select two women from the set that we have three women. So from three you have to select two women. So this is the next answer. 2c1 times 3c2. I hope this combination problem is clear to all of you guys. So we will build this up a little more right now. So now we will do is, what we will do is, it's called as circular permutation. Okay. So the reason today I discussed all these problems like this, you see, one of the reasons, it's not the all reasons, the four letter words can be rearranged within itself by 4 factorial ways. Then I discussed similar problem, but it's like two numbers are same, so we also divided it by 2 factorial, but nonetheless it's a four letter word, so it can be rearranged first in 4 factorial ways. Since these two are same, it can be divided by 2 factorial. Okay, so right here, let's say let's say there is another thing, in a1, a2, a3, so there are like n letters are there. Okay, n letters. How many ways can they be rearranged among themselves? All are different. Okay, in a linear combination. Linear, not, I don't want to use the linear combination word, linear scenario. Okay, the number of ways n letters can be rearranged among themselves will be, we already discussed, right? N factorial, right? Npn, npn, n factorial, or n times n minus 1 times n minus 2, up it will go up till 1, right? N spots are there. First spot can be filled with n ways, next with n minus 1, it will like that, it will go up till 1, right? Now let's say we have a circular combination scenario. Now they want us to place this a1, a2, a3, an in a circle, and then they want us to decide how many arrangements are possible if all these a1, all these letters a1, a2, a3, a4, a5 up till an, if they are placed in a circle. So what we will do in such a scenario is, you see, it doesn't matter if we put a1 here. Sorry, it doesn't matter if we put a1 here or here or here. Every all the spots are same, right? In a circle everything is same wherever we put the first letter a1. So let's put the first letter a1 at some spot here. Okay, now we will fix this spot, we will pin this spot. This spot is fixed, and relative to this spot, all the other spot a2, a3, a4, up till an, they will change. We have to fix this spot. And or else if we, because this is a circle, so relate this one spot needs to be fixed, otherwise y- you cannot make the difference, right? So when we fix this spot, all these other with respect to a1, they can say okay, a2 can say I am sitting next to a1 in this scenario. In the next scenario, a2 can say I am sitting here, three spots away from a1, right? Now if we don't even fix this spot, a1 can be again here, right? A2 is again here, and now we are thinking it's a different scenario. A1, A2, but again A1, A2 is here. And similarly, let's say the arrangement is A1, A2, A3, A4, A5, AN, and again in the one scenario it is A1, A2, A3, like that up till here it's AN. And we will consider this is a different scenario, right? Because A1 is not here this time, A1 is here this time. But you see, in a circle it doesn't matter where, if a1 is here or a1 is here, right? Both, it's the same scenario. So we have to fix one spot, we need to fix one spot, and with respect to that spot, the other combinations, other permutation needs to be determined. Okay, so let's say we fix this spot. How many are left? How many letters are left right now? There were n letters in the to start with. Now we have n minus 1 letters left. When we fixed one spot. Okay, so how many ways these n minus 1 letters can rearrange within themselves, among themselves? They can rearrange in n minus 1 factorial ways. The rearrangements are possible. I hope this concept is clear to you guys. So so to for a conclusion here, the circular combinations, if there are n items, if they need to be in a circular permutations, in a circle, if they need to be placed in a circle, the circular permutation will be one less than that. And mutation, and you guys understood why it should be one less than that, right? Because with relative to one item we can place the other n minus 1 items. Okay, and also let's say if this is a garland is there, because there are scenarios, let's say a garland, and we need to place some flowers on that garland, something like that. I don't know. Let's say one is here, a2, a3, like that up till an is here. Now let's say this is a garland. How many ways can you? This is an important example. Okay, so please pay attention. It's not that I'm just saying something. This is important also. If let's say it's a garland, how many ways they can be rearranged? Okay, so you see, it's a garland. It doesn't matter if it is clockwise or if you just rotate this thing completely, like completely rotate it. Okay, and now in this case, let's say this is a1 and this is an minus 1. Same thing up till a1 here. Sorry, a2 here. Okay, so when you rotate it back, you get this thing, and the other way around, you get this thing. Basically, 180-degree rotation. Okay, I hope you guys can understand, because it has to come out of the plane basically. Okay, I'm not able to show it very well. So this part has to come out of the plane, and when this will come here. So you see, in a garland, both the scenarios are same, right? This a2, a3, a4, an, a1, and a1, an, a minus 1, a2. They are same, right? It doesn't matter. So in this case, if it's a garland type situation where if you rotate it, it will be same. Two, so basically these two configurations will be same, then the total number of circular permutation in such scenarios will be, we already got it's n minus 1 factorial. So for two such cases we have to consider it as one case, so we have to divide this n minus factorial divided by 2. Okay, So I hope this is clear to you guys. So in such scenario we have to divide it if both the scenarios are same. If we rotate it by 180-degree in a circular permutation, then we have to divide this by 2, right? Okay, let's move on. This is the last thing that we will discuss today in circular permutation. So let's say now, what will be the let's solve a quick circular combination problem. Circular combination of in different things taken r at a time. So what would be the circular combination of in different things taken r at a time? Okay, so let's say you have n different things, a1, a2, an, and up till here it is r, right? This is ar, and then it goes up till n minus an. Okay, so what is a circular combination of n different things taken r at a time? So basically it is very simple, right? First you have to select r among n, and then only you can do that circular permutation, right? You can change it in different ways. So first your job is to select r from n. That's a step 1. So what is a step 1? Select r items from n items. There are various ways to do this type of problem. Any problem can be done in various ways, right? So this is just one way that I'm discussing. So always keep your mind open to like various ways. So it's not like this is the only way to do it, but I'm discussing this way. So circular combination of n different things taken r at a time. So we select r items from n items. First, this is of step 1. And what is a step 2? Rearrange rearrange the r items in a circle, whatever. Okay, and these two conditions, there is an and in between step 1 and step 2, because both needs to happen. First you need to select r items from n items, and what you need to do, rearrange the r items in a circle. So what I now that I have wrote the problem steps, I hope you guys can do the solution. Let's say what will be step 1. For step 1, what is a mathematical expression for step 1? How can we select r items? Just select. Okay, it doesn't matter whatever the combination, those things doesn't matter, we just need to select r items first. How many ways can we select r items from n items? We can select in ncr ways, right? You can select in ncr ways, right? So when we select these r items, now we need to rearrange the r items in a circle. Now permutation is important because all the different scenarios are different right now. But first exercise, we just took that r items. Okay, what are the r items that needs to be in the circle? Let's in a table, what's the r items that needs to be placed along the table? Okay, that's the first thing. And so there will be a multiplication. Now we rearrange the r items in a circle. So this is a circle. It is a1, a2 up till ar. So now there are r items in this circle. What did I say? If there are r items, if there are n items, they can be rearranged in n minus 1 factorial ways. So if there are r items, they can be rearranged in r minus 1 factorial ways, right? So this will be ncr times r minus 1 factorial ways. So we also know ncr. What is ncr? It is npr divided by r factorial. I guess you guys can understand why I wrote it. NCR is n factorial divided by r factorial times n minus r factorial, right? And this part is NPR formula, right? N factorial divided by n minus r factorial is NPR, right? So this is NPR divided by r factorial times r minus 1 factorial. So we can write this as npr divided by r factorial means r times r minus 1 factorial, and this is r minus 1 factorial, right? So we can get it as npr divided by r. Okay, so these are the things which I wanted to discuss in this class. So more or less your permutation and combination is covered. So we discussed all the basics of permutation combination. So we discussed just a quick summary in these two videos that we covered, permutation combination 1 and permutation combination 2. If I make some later videos, it will be only on problem solving some difficult problems. But the main concept building is already done in these two concepts, and after this it's only application. Okay. So what are the things that you guys need to understand very well in permutation combination? And concept, very well, and concept. Number two, or concept. Basically, you need to understand these two together, and or concept. Okay. Number three, after that, how we defined NPR, how we formula, how we got it from and or NPR, how we got NCR. Okay. And if it is like a same letter word, what will be what will be npn? It's n factorial, right? Arrangement of n letters. Okay, we are arranging n letters, so it's like npn. We are selecting those n spots, right, from n spots. That's n factorial, and order is important. So if there are like let's say r are same number, same letters are there, are same letters from n letters, then how many arrangements are possible? Npn divided by r factorial, that is n factorial divided by r factorial. What is this scenario? N letters, r letters same, r letters are same. So total number of arrangements. So we discussed this in detail also. Okay, then we solved some problems in NCR also, right? And at the end, we discussed what is circular permutation. Okay, we also discussed this circular permutation, which is if it is n, we need to rearrange n items in a circular permutation. What it will be? It will should be relative to one item, right? So it should be n minus one factorial. So these are the points that I discussed in this video. In case you find the video valuable and useful, please like this video and subscribe also to our channel. So for more such content, I hope you find this useful. Thank you so much. Bye.